Okay, problem number 4. Find the derivative of this ellipse given the parametric equations. So the first thing we need to do is convert it to rectangular form. So look at our x equation. X equals 3 cosine theta minus 2. That tells me on the bottom I will have a 3 squared is 9. The minus 2 tells me I will really have a plus 2 in my factored form right there. Plus, look at the y equation. I have a y in the top with something squared over the 4 in front of the sign tells me I have a 4 squared 16 in the bottom there. The plus 1 tells me that when it's in factored form, I need a minus 1. That all equals 1. So my first step when I am writing the derivative of a conic like this is I write the denominators as coefficients. So I write that as 1/9 times x plus 2 quantity squared plus 1/16 times y minus 1 quantity squared equals 1. And now I want to take the derivative using the power rule. So I multiply the power on that set of parentheses, that 2, I multiply that power by the coefficient. So 2 times 1/9 gives me 2/9 times what's left, x plus 2 stays there, the power drops to a power of 1. So it's not worth writing, but there you go. Plus, do the same thing here to the y term. 2 times 1/16 is 2 over 16 times y minus 1. Leave the inside the same, drop the power by 1. But now, anytime you multiply by y, you have to, anytime you take the derivative of a y term, you have to multiply by the derivative of y with respect to x, dy dx. Every single time you take the derivative of a y term, you have to multiply by dy dx or y prime, whatever you prefer. Equals, well, what's the derivative of 1? Well, derivative of any constant is 0. Now check this out. If I divide everything by 2, every single term by 2, this gets simpler. 1/9 times x plus 2 plus 1/16 times y minus 1 dy dx equals 0 divided by 2, still 0. Now, our goal here is to isolate dy dx. So at this point, it's just algebra. So we have stuff times dy dx, we have stuff added to our dy dx expression. Which do you undo first? You undo the addition first. So we need to subtract that over, which means I'll have 1/16 y minus 1 times dy dx equals x plus 2 over 9, but it's been subtracted, so negative x plus 2 over 9. Notice I moved that 1/9 just underneath the x plus 2. Totally fine to do that. All right, well now I have multiplication with this dy dx, so I need to undo that. So I need to multiply that 16 up to get it by itself, and I need to divide that y minus 1 down to undo it from that dy dx, and that will give me my final answer of dy dx equals negative, I've multiplied that 16 up, so negative 16 x plus 2 divided by 9 times, I'm dividing the y minus 1 down, so y minus 1 right there. And that is my derivative. I have done it.